In this video, we'll be converting from polar coordinates to rectangular coordinates. Our first problem is to convert the point 630, or it could be written this way, 6 at 30 degrees, to rectangular coordinates. Now we know that the 6 represents the distance from the origin to the point, and the 30 represents the angular rotation. So let's sketch this point. Now we're going to rotate 30 degrees. So this angle is 30. And then we're going to go out 6 units from the origin to the point. So this distance is 6. Now we're asked to convert this polar coordinates to rectangular coordinates, which means that we need to find some x value and then some y value to get to that point. And a right angle is right here. So let's label this as x and this is y. Now since we have a right triangle, we can use right triangle trig. The x is the adjacent side and we know the hypotenuse. So we can use cosine of angle 30 equals adjacent, which is x, over hypotenuse, which is 6. To solve for x, multiply both sides by 6. These will cancel, and I get x is equal to 6 times the cosine of 30. Then, to get our y value, that's the side opposite the 30 degree angle, and we have opposite and hypotenuse, so we'll use sine. Sine of 30 is equal to y over 6. To isolate the y, we want to multiply both sides by 6, and these will cancel, and so we have y is equal to 6 sine 30. Let's use our calculator then to get these values. Make sure you're in degrees. And this calculator, that shows up right here. So we want 6 times the cosine of 30. 6 times the cosine of 30. Looks like x is approximately 5.20. And then 6 sine 30 would be 3. So then our rectangular could be written as an ordered pair like usual, 5.20, 3, or we could write it with vector notation, and that would be 5.20i plus 3j. And the little carets are the vector notation. So we could write either one of those. Let's try another one. The problem is to convert -12, -240 to rectangular coordinates. So again, let's draw a sketch. We have a -240 degree rotation, so we'll go clockwise this time. 180 would be to the negative x-axis, and then 60 more would put me right about here, and that is our -240 degrees. But now we have to consider the fact that our r value is negative. When we have a negative r value, we don't use this vector. We have to add 180 to this and use this vector. So this is the vector we're going to use. We have 12 is the distance from the point to the origin. To find our angle that we'll need, we'll need to find this reference angle. Well, we said this was 180 to the negative x-axis, and if we take 240 minus 180, we'll get 60 degrees. So this angle is 60 and this angle is 60. And so those are vertical angles and they're congruent. Now let's do a shorter method on this one. Instead of using our right triangle trig functions, we have a 60-degree angle. That means we also have a 30-degree angle here. So we can use what we know about 30, 60, 90 triangles. We know the hypotenuse is 12, so that means the side opposite the 30 is going to be half of that. So this measure has to be 6. Then the side opposite the 60-degree angle is half the hypotenuse times the square root of 3. So we'll have 6 square roots of 3. Now keep in mind that since we're going down here, this is going to be a negative value. Right? So our point then here has coordinates. The x goes first always, so 6 and then negative 6 root 3. Or we could write that with vector notation. So 6 minus 6 root 3. Now this is I and j. So either one of those is fine. And this one we have 156.2 degrees, which will be in quadrant 2. And the R value is 3.2. This angle of rotation is 156.2. And we want to get to this point. It's our right angle, this is our x, and this is our y. Now we know that the cosine of theta is equal to x over r, and the sine of theta is equal to y over r. So we can multiply both sides by r to get a quick way to find our x value, and multiply both sides by r to get a quick way to find our y value. So let's try this with these formulas. So our x value will be the r 3.2 times the cosine of 156.2. So we get approximately negative 2.93. And then our y, we'll use the formula r sine theta. So 3.2 times the sine of 156.2. And we'll get y is approximately equal to 1.29. So our answer then, we would write our rectangular coordinates as an ordered pair, negative 2.93 and 1.29. Or we could write it with vector notation, negative 2.93i plus 1.29j.